Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. This second video lecture of week 13 for the course Applied Linear Algebra is the continuation of my previous first video lecture of week 13. In the first video lecture of week 13, we have discussed equation of plane in 3D space. Now in this lecture, we are going to discuss equation of plane in 3D space with the examples. So for the explanations of equation of plane, we are going to solve some examples. Now you see over here, suppose example number 1. To find an equation of the plane through the points 2, 4, -1 with the normal vectors n is equal to 2, 3 and 4. I have already told you in the previous video lecture that for the equation of plane in 3D space we need one point on the plane and one normal vector for the plane. So this is actually x0, y0 and z0, and this is the normal vector whose components are a, b and c. The value of a is 2, the value of b is 3 and the value of c is 4. Now equation of plane in standard form, this is actually called point normal form. Point normal form mean one point and one normal vector are given. So the equation of plane in standard form, a into x minus x0 plus b into y minus y0 plus c into z minus z0 is equal to 0. This equation is the scalar equation of the plane through the points p0 and with normal vectors n. Now putting the values of the normal vectors components, a is equal to 2, b is equal to 3, c is equal to 4, x0 is equal to 2, y0 is equal to 4 and z0 is equal to -1. So we see that an equation of the plane is a into x minus x0. So the value of a is 2, x minus x0, the value of x0 is 2, plus b into y minus y0, the value of b is 3 and the value of y0 is 4, plus c, the value of c is 4, z minus z0 and the value of z0 is -1. So this is the standard form of equation of plane. Now after simplifications we obtain the equation of plane in general form, 2x plus 3y plus 4z is equal to 12. This is actually the general form of equation of plane, ax plus by plus cz plus d is equal to 0. So now another example, suppose we have 3 points. To find an equation of the plane that passes through the points p. P components are 1, 3 and 2. Q another points whose components whose coordinates are 3, -1 and 6, and R is the third points whose ordinate are 5, 2 and 0. You see over here, this is the plane and there are 3 points on the plane P, Q and R. So we need to find the equation of plane. For the equation of plane, we need one point on the plane and one normal vector. So we can choose any points P, Q and R from these 3 points. We can choose any point for the equation of plane. But the main question is that where is the normal vector? So we need to find the normal vector to the plane. So for the normal vector to the plane, you see over here, this is a plane and this is like a rectangle. So first of all, construct any two adjacent vectors. Suppose PQ and PR are the adjacent vectors. So you see over here the vectors A and B corresponding to the vector PQ and PR. So we need to find the vector PQ, these two adjacent vectors PQ and PR. So PQ vector represented by this small a, and PQ mean Q minus P. Subtract the P coordinates from the Q coordinates, we obtain a vector A whose components are 2, -4 and 4. Now construct another vector PR. PR mean R minus P. Subtract P coordinates from the R coordinates. PQ mean Q minus P. Subtract P coordinates from the Q coordinates, and p r mean r minus p. Subtract the p coordinates from the r coordinates, we obtain another vector b, 4, minus 1 and minus 2. So since both the vector a and b lie in the plane, their cross product a cross b is orthogonal to both to the plane and can be taken as the normal vector. So first of all, find the cross product of these two vectors a cross b, and we know that by a cross b we obtain a vector that is perpendicular to the vector a and the vector b. Vector a and vector b, both vectors lies in the plane, and a cross b will be the orthogonal to vector a and orthogonal to vector b. So this is actually the normal vector for the plane. Now how to find the cross product of these two vectors? By using a simple determinant. In the first row we put I, j, k for directions, and in the second row put the components of vector a, and in the third row put the components of vector b. And now expand this determinant by first row, by second row, or by any columns. We obtain the determinant value is 12i plus 20j plus 14k. So this is actually now the normal vector. Now with the point, suppose we choose the point P, and we can choose the point Q, point R, any points. In these 3 points, suppose we choose point P as initial point and the normal vector n, and now equation of plane is a into x minus x naught plus b into y minus y naught plus c into z minus z naught is equal to 0. So the value of a is 12. You see over here the normal vector. This is the value of a, this is the value of b, and this is the value of c. So the value of a is 12. 12 into x minus x naught, the value of x naught is 1, plus b, the value of b is 20, y minus y naught, the y naught value is 2, and for c into z minus z naught, the value of z naught is 3. And now the equation of plane in general form, after simplifications we obtain 6x plus 10y plus 7z is equal to 50. So putting the value of a, b and c and the value of x naught, y naught and z naught, you see over here a into x minus x naught, the value of a is 12, x minus x naught, the value of x naught is 2, plus b, the value of b is 20, y minus y naught, the value of y naught is 2, plus c, the value of c is 14, and z minus z naught, the value of z naught is 3 is equal to 0. So this is the standard form of equation of plane in 3D space. Now after simplifications we obtain the general form of equations of plane 6x plus 10y plus 7z is equal to 94. Now another example. For another example, note that, dear students, two planes are parallel if their normal vectors are parallel, and I have already told you in the previous video lecture that when the normal vectors of two planes are perpendicular, then the plane will be perpendicular, and if the normal vectors of two planes are parallel, then the planes will also be parallel. Now to find the angle between these two planes, x plus y plus z is equal to 1 and x minus 2y plus 3z is equal to 1. For the angle between these two planes, first of all choose the normal vectors for these two planes. Since the coefficients in the first plane 1, 1 and 1, so these are the values of a, b and c, ax plus by plus cz. So by comparing this equation to the general form, we obtain the coefficient, the a value is 1, the b value is 1, and this c value is also 1. So this is the first normal vector for the first plane. Now in another equation of plane, the value of a is 2, the value of b is minus, the value of a is 1, the value of b is minus 2, and the value of c is 3. So another normal vector in 2 whose components are 1, minus 2 and 3. Now to find the angle between the planes, we use this formula cos theta n1 dot n2 divided by n1 magnitude dot n2 n2 magnitude. So the scalar product, the dot product of these two vectors, 1 into 1 plus 1 into minus 2 plus 1 into 3. You see over here the scalar product of these two vectors, 1 into 1, 1 into minus 2 and 1 into 3, divided by the magnitude of n1 vector, 1 square plus 1 square plus 1 square. We again obtain 1 plus 1 plus 1 under root, and the magnitude of the second normal vector you see over here. This is the second normal vector, so square of 1, square of minus 2 and square of 3. So 1 square mean 1, minus 2 square mean 4 and 3 square mean 9. So after simplification we obtain 2 divided by under root 42, and the theta will be equal to cos inverse of 2 divided by under root 42. Now using a scientific calculator we obtain angle approximately 72 degree between two planes. Now another example, to find the distance between the parallel planes. These are two parallel planes. These two planes never intersect each other because the planes are parallel, and by the normal vectors, from the normal vectors, since the normal vector of the first plane are 10, 2 and minus 2, and the normal vector for the second plane is 5, 1, minus 1. The coefficients a, b, c are 10, 2 and minus 2. The value of a is 10, the value of b is 2, the value of c is minus 2 in the first plane. So this is the first normal vector for the first plane, and the second normal vector for the second plane is 5, 1, minus 1. So this normal vector is a scalar multiple of this vector. If we multiply this vector with 2, 2 5 the 10, 2 1 the 2 and 2 minus 1 the minus 2. So this vector actually equal to, suppose this is n1, so n1 is equal to 2 and 2. n1 is a scalar multiple of n2. So in this case these two vectors are parallel. When one vector is scalar multiple of other vector, then vectors are called parallel vectors. So the planes are now parallel, and we need to find the distance between these two planes. I have already told you that when the outside point for the plane is not given, then first of all choose any one point on any one plane. You see over here, to find the distance d between the planes, we choose any point on one plane and then calculate its distance to the other plane. In particular, if we put y is equal to z is equal to 0, suppose we put both these two variables equal to 0 in the equation of the first plane, we get 10x is equal to 5. You see over here, putting y 0, putting z is equal to 0, we obtain 10x is equal to 5. So x is equal to 5 by 1 over 2. 5 by 10 mean 1 over 2. So this one point 1 over 2, 0 and 0 lies on the first plane. So now we can find the distance of this plane to the second, the distance between this point and the second plane. By using the formula, the distance between this point and the second plane, 5x plus y minus z minus 1 is equal to 0. So just replace x, y and z by this point. This is actually the value of x, the value of y and the value of z. So 5 into 1 over 2, 1 into 0, minus 1 into 0, minus 1 absolute. And now the coefficient of x is 5, 5 square, the coefficient of y is 1, 1 square, the coefficient of z is minus 1, minus 1 square, under root. And now after simplifications we obtain 3 by 2 divided by 3 and 2 under root 3. And after simplifications we obtain under root 3 divided by 6. So the distance between the plane is under root 3 divided by 6. Now another example, to find the equation of the plane containing the points P, Q and R. I have already told you about the equation of plane when 3 points for the plane are given. So first of all, construct two adjacent vectors. Suppose PQ, suppose this is P, this PQ represented by A, and suppose QR is another vector. PQ mean Q minus P. Subtract the P coordinates from the Q coordinates. We obtain minus 4i minus 2j minus 2k. And now the QR vector, R minus Q. Subtract Q coordinates from the R coordinates. We obtain 3i minus 2j plus 2k. And now the cross product of these two vectors by using a simple determinant. First row contain ijk, second row contain the components of the first vector minus 4 minus 2 minus 2, and third row contain the components of the another vector 3 minus 2 plus 2. Now by expanding this determinant by any row or by any column, we obtain minus 8i plus 2j plus 14k. Now this vector is orthogonal to both PQ and QR, and since PQ and QR lies in the plane, so this is the normal vector. Therefore the equation of the plane containing the points P, Q, and R, we choose any point. Suppose we choose point P as initial point. This is x naught, this is y naught, and this is z naught, and this is the normal vector. A value minus 8, B value 2, and C value 14. So A into x minus x naught minus 8 into x minus x naught, the x naught value is 2, plus B, the value of B is 2, y minus y naught, the value of y naught is 4, plus C, the value of C is 14, z minus z naught, the value of z is 2. So this is the standard form of equation of plane. Now after simplifications, we obtain minus 8x plus 2y plus 14z and plus 16 minus 8 minus plus 16 minus 8 minus 8 and minus 48, 14 to the 28. So after simplifications, we obtain minus 8x plus 2y plus 14z is equal to 20, and after simplifications dividing both sides by 2, we obtain minus 4x plus y plus 7z is equal to 10. So this is the equation of plane when points are given for the plane. When points are given, then first of all construct two adjacent vectors from these points PQ and QR, suppose, and these two vectors lies in the plane. So if we find the cross product of these two vectors, then the cross product actually will be the normal vector for the plane, because this vector is orthogonal to both PQ and QR. So this is the normal vector, and we can choose any point from these 3 points as an initial point P naught. So this is now, suppose this is P naught, and this is the normal vector components, A value minus 8, B value 2, and C value 14. So for the equation of plane, we need one point on the plane and one normal vector to the plane. So in this video lecture, I told you about the equation of plane with some examples for practice, and how to find the distance between two planes, how to find the angle between two planes. You see over here, this is the distance formula, how to find the distance between, and this is the angle angle. We can find the angle between two planes by using this formula. Cos theta is equal to n1 dot n2 divided by n1 magnitude and 2 magnitude. n1 and n2 are the normal vectors for the planes. We need to find the angles between two planes. So n1 and n2 are the normal vectors of the planes, and we can use, this is the distance formula, d is equal to ax1 plus by1 plus cz1 plus d absolute divided by a square under root a square plus b square plus c square. So just put the value of the points in place of x, y, z, and the square root of the coefficients of x, y, and z, sum of square root of the square root of the square of the sum of the coefficients x, y, and z. So we can easily calculate the distance between a points and a plane. But when two planes are given, then first of all choose any one point for the first plane, and then find the distance of the points and between the other planes. And now this is the end of this segment. Thank you. Allah Hafiz.